So Apache Spark. So let's see what is meant by Apache Spark, what are all the different components of Apache Spark, how it will be very useful for processing the data on top of the Hadoop system. So in this session we are going to discuss about what is Apache Spark, why we need Apache Spark. So Apache Spark basis. So some kind of RDD preparation. What is meant by RDD? What are all the actions? Different actions, transformations. So all those things with respect to the cluster setup as well. We'll see one by one. So before going to exactly what is RDD and all those things, let's see what is meant by Apache Spark. So as I said here, so Apache Spark is an open source, fast and general engine for large scale data processing. For data processing we have MapReduce in Hadoop system. So even though, why do we need this Apache Spark? So in some cases, if you want to process your data, so whatever the data which we are going to process using MapReduce, it's a kind of batch processing. So mappers are going to be generated, so it is going to be so it is the way that mappers initiate depends upon the split size. So that if multiple splits are there, those many number of mappers are getting initiated. So each mapper by mapper it's going to process the data. So it takes some time to process the data which was there in the HDFS layouts. But Apache Spark is fast. It processes the data very fast. So also the data processing on top of the large scale clusters as well, it processes the data very effectively. Let's see how it is going to process. So what are all the different components in detail. So also the next thing is it is written in Scala, because Scala is one of the language. So using that language this Spark was designed. So basically it was developed in the AMP lab at UC Berkeley. So AMP lab. So it handles both batch, interactive, real time, all kind of data. But coming to MapReduce, only batch kind of data, batch environment data, it is going to process MapReduce jobs. Coming to real time environment, it won't process the data which was there in the real time, related to the real time scenarios. So MapReduce will process that one. So in these situations, so we should need Apache Spark to process such kind of data. So here it could process batch data as well as interactive and real time environment, real time data as well. So real time interactions as well. Okay. So here it is 100 times faster than MapReduce. Let's see how. So what is the key to process the data in that much of fast? So let's see that one in detail. Okay. So it is the way that we are going to interact with this Spark is most of the things are predefined, so we are going to use them and then we are going to customize our code. That's it. Okay. So it provides the APIs, Java API, Python API, Scala API, everything was there. So if you see this diagram, so this is the word. So batch processing. So it will be available streaming kind of data, interactive streaming kind of data. When we are to some kind of real time data is there, so we want to answer we want to produce that result very in a real time manner, so that this framework will be useful to process the data which was there in the HDFS layouts in a very real time manner. So Apache Spark will be useful. So these are all the different subparts of the Apache Spark core engine. So Spark SQL is there, Spark streaming is there, mlib machine learning, GraphX, so to process the graphical kind of data. So mlib is for to process machine learning algorithms related data, like Spark streaming is there. Okay, and then Spark SQL is there. So if at all you want to process some data which was there in the Hive table, you can load into this Spark variables, and then you can interact with those table kind of data using Spark SQL kind of stuff. So these are all the different parts available with respect to the Apache Spark. So this is the brief history of the how Spark comes into the picture. So in 2002, so Google present MapReduce, okay, and then in 2004 MapReduce paper was presented. In 2006 Yahoo presented some paper on the same thing. 2008 also some paper presentations, so like that way, which are related to the MapReduce. But coming to 2010, Spark paper was presented. So in 2014, it was at high level. So in in 2014 full release was done. So that clients try to interact with this Apache Spark. So because its interactiveness, its fastness, so that it produce the result in a very real-time manner. So whatever the applications which require these kind of features, so Apache Spark would be the perfect solution in these scenarios. So it's very recently it has been added to the Hadoop ecosystems. So these are all the motivation factors for why we are going to use Spark. MapReduce is insufficient for applications that repeatedly reuse the same working set. So whenever you want to use same data entire application, so MapReduce is insufficient. Why? Because it's keep on producing the mappers on that one and then try to run that one. That it's a kind of batch kind of environment. But coming to Spark, so we can put the data into the one memory area, so that all the clusters, all the processors, so that that can use that that data, so that effectiveness would be very so we can handle the data very effectively. So some iterative algorithms, interactive data minings, so so in this scenario, some iterative algorithms, interactive data mining techniques. In those scenarios, so MapReduce jobs are insufficient. MapReduce, although it can process that kind of environments as well, it is insufficient. Why? Because so it's keep on rendering into the same working set of the data. But coming to Apache Spark, we can put the data into the one of the memory areas, so that all the process can able to use that one. So that facility was provided by the Apache Spark, so that it is efficient. So that is why we need to go for using the Apache Spark. So right, so this is a sample picture showing what are all the iterative algorithms, iterative, what does it mean, and everything. So this is iteration 1, so it produces some result. So iteration 2, iteration. So here we are using the same, we are generating the same iteration. It would be very insufficient. Yeah, if at all we are putting that whatever the data which are going to be iterating multiple times into the some memory area, distributed memory, like some working set in the RAM, so that all the iteration can able to use that the same data, so that it will be available for all the iterations, so that the data accessing would be very fast, and then data we could handle the data in a very efficient way. So this is what the iteration which are going to be handled in the Apache Spark, right? So these are all the cluster options. So we can set up locally or in a fully distributed manner. Anything it could be possible for setting the Hadoop cluster. So these are all the cluster options. So locally, so without any distributed environments, locally also we can set up this Apache Spark cluster. If at all you want to set up the cluster in the fully distributed manner, you can set up that one as well. So here, like every programming, like ecosystem, like Pig, Hive, Shell, HBase, Pig, Hive, Scoop, Pig, Hive, HBase. So here is also some shell kind of environment. Interactive shell is there, so that we can connect to that shell and then we can execute our program whatever as per the requirement. So these are all there are a couple of shells available here. One is Scala shell, another one is Python shell. So to enter into the shell, this is the option /bin/spark -shell. It will take you to the scalar shell. Likewise, if at all you want to use, Python shell /bin/py_spark, so that it will take you to the Python shell. So every Spark application requires Spark context. So that is the main entry point to the Spark API. So that we can connect to the shell, and then we can create some Spark context, and then we can interact with the Spark API. So SC is the variable available in the shell level. So this is the main thing. So resilience distributed data. So this is what this is the core part of the Apache Spark. Using that, we can achieve some real-time data processing on top of the Hadoop system using Spark. So RDD is the core thing. So it is nothing but resilient distributed data. Resilient means data in memory is lost, it can be recreated. Distributed means stored in memory across the cluster. Data set means initial data can come from a file or to be created programmatically. So that is nothing but resilience distributed data. That is the fundamental unit of data in the Apache Spark. So RDD, it is an immutable distributed collection of data which is partitioned across machines in the cluster. So this is the core thing in the Apache Spark to achieve the real-time data real-time data processing as interactive data processing. So this is nothing but we are going to create some working set in the memory using RDD. So RDD is nothing but itself is a working set on top of the in the memory. So it is a basic fundamental unit of data in the Apache Spark. So how to create RDD? So how we are going to create RDD? So this is the way. So SC is a variable to create a Spark context, right? So Spark context, if you can go back, so this is the Spark context is the main entry point to the Spark API. Using that, we are going to create resilient distributed, so that it will put that whatever the data set we are going to be created into the memory, so that it would be accessible for all the process or all the servers, right? So SC.text file, so whatever the file we are mentioning here, so it will create some RDD, so that we can access this file from anywhere, any machine, any parallel processing, so like that way. So from a collection like this way, so SC.parallelize, so whatever the data we have, so that it will create some RDD. So from one RDD to another RDD is also possible. That is nothing but transformation. So we can create that one using the last point. So this is the way. So RDD operation, what are all the basic operations we are going to perform with respect to the RDD? So one is action, another one is transformations. Okay, so action is nothing but we are getting result out of RDD. That is nothing but action. So transformation is nothing but we are creating new RDD using existing RDD. That is nothing but transformation. So if at all we are getting value out of one RDD or nothing but result out of RDD, that is an action. That is an action. If at all we are creating new RDD from the existing RDD, that is a transformation. Data in RDD, important point is data in RDD is not processed until an action is performed. So these are all the different functions available for the RDD actions. So reduce, collect, count, first, take. This is the description of the each and every function. So likewise, so save file, save as text file, save as sequence file. So these are all the different RDD actions. So but coming to transformation, these are all the transformations. Map, filter. Transformation is nothing but use from the existing RDD we are creating new RDD. That is nothing but a transformations. So these functions help us to create the transformations. So map, filter, flat map, sample, union, distinct, like this way. Yeah, so these are all the transformations: co-group, Cartesian. Yeah, so this is what at high level Spark API. So cluster, we can set up the cluster and then we can store the data on top of HDFS, and then we can interact with the data in a very real-time manner. Okay, so this is the cluster-wise terminology. So cluster terminology: a cluster is a group of computers working together. So cluster is nothing but it's a group of computers working together. So usually runs on HDFS. In addition to Spark standalone, we can set up the Spark on ARM cluster as well. So a node is nothing but individual computer. So here master, likewise, Hadoop or HBase. So here is also cluster configuration required. So here Spark master is there, Spark worker is there. So whenever those services are running, we can consider that those servers or those nodes to create the RDDs and then to process the RDDs. So daemon is nothing but is a program running on a node. So each performs different functions in the cluster. So master node manages the distribution of work and the data to the So Spark driver is there. That is the driver program. Is nothing but Spark context. So which is the using that only we can connect to the Spark API. So master node. So master node, here we have worker nodes. Spark master is there. Spark workers are there. In the worker nodes we have executors are there. So those responsibility is to execute the task out of it. Okay. So here the main program, either the Spark shell or Spark application, creates a Spark context configured for a cluster, communicates with the cluster manager to distribute tasks or executors. So executors are tasks. Okay, right. So this is the way we are going to start the Spark shell. Set the Spark master. So this is the path we are going to edit, and then we are going to 7077 is the default port for the Spark master. Okay, likewise Spark master, Spark worker. So Spark work master is for responsibilities to maintain the metadata. Spark worker nodes are responsibilities to store the data, to store the values out of an action, also to create the RDDs, to process the RDDs. Okay, this is the cluster setup. So Spark driver program or context can interact with Spark master, and then master distributes the logic out of it on top of the Spark workers to the Spark workers. Executors are responsibilities to take that work and then take the task and then execute it. So these are all the difference between data node and Spark worker. So data nodes, here we have task tracker services are running. In the Spark node we have executors are running. These are all the threads running with respect to the Spark workers. Executors are the threads. So this is the in association with the Hadoop cluster, Spark cluster, right? So this is a high level API. Faster and easier development is there, so there is no latency. So we can use this one processing the real-time data. So it is up to 100 times faster than the map reduce. Okay, so that's it about Apache Spark. Let's see some of the programs. So I have designed some programs to show you. So this is the way this is the Scala language. Using that we are going to create some RDDs, perform some actions and all those things. Okay, so these are all the programs. So if at all you want to create RDD out of some list of data, so as I said, this is what's that, a collection, how we are going to create the RDD. So this is the word from a collection, this is the word, this is the RDD, this is the word, this is the way we are going to create the RDD from the collection. Let's see that one. Let's log into the quick start VM. Okay, here I am open the, I'm just opening, or else here in the Hue there are query editors are there. In the query editors, Spark editor is also there, so that you can connect to that one and then you can execute all these programs. Either is fine. Here query editors, so normally here is not there, but in new versions we have, you know, Spark. Spark is also available as a query editor. Okay, here simply ls cd space on it. Right, so Spark hyphen shell, so it will take you to the Scala shell, right? It will take you to the Scala shell, right? So it's whenever you type Spark hyphen shell from anywhere in the command line, it will take you to the Scala shell. So this is the way we are going to create the RDD. So Spark version 1.3.0, it has been installed in this quick start VM. Spark context available as SC, so it is displaying all the related information. So now Scala shell is open. So whenever you log into the shell, Spark shell, so by default shell is Scala shell. So like this way we can create. Program 1 is to create RDD from a collection. So here I am val, so this is a Scala language. Val data equal to 1 to 100, right? So val data equal to 1 to 100. So it will create some collection. So out of that we are creating sc.parallelize the data. So collection has been created. After that val some other data equal to, right, val data equal to sc.parallelize, right, PARALLE right. So this is nothing but this is then RDD. So if at all you want to store this data, there are another method available. So this is the way we can store this data into the right, save as text file, and then we can give the path as well. So this is the way we are going to save this data. Dot save as text file, and then here I am giving /tmp/spark rdd out. No. Right. So it is writing the data into the that particular path. Right. So let's see the data. Hadoop FS. -ls / tmt/. Spark is here, right? Yeah, this is the file, right? Sorry. Or else you can print the data as well. Yeah, so it contains that data. If at all you want to save the data, you can save that one, you know, using save as text file. So the Spark, the thing is nothing but, so we have taken the collection and then we have made it as a RDD. If at all you want to print that RDD, this is the command. So RDD dot collect dot for each println, so that it will print the whatever the contents of this particular RDD. So this is the function. Using that you can print the whatever the data which was there in the particular RDD, right? So this is what, if at all you want to save that one, I will show. This is the way you can save that. I will show. I will give that one as well, right? So our next program is create RDD from file and perform action and transformations. So if at all you have some file into your HDFS layouts, you can take that into the so if at all you have a file in HDFS, you can make it as an RDD using sc-spark context.text file. So this is nothing but the file which was there in the HDFS layouts. So you can take that into this is the RDD, right? And then using that you can count the variables out of it, or if you want to print the first data, you can using first function, you can do like that way. So if at all you want to count how many lines are there, so that is nothing but transformation, right? So So filter is a function, transformative function, and then lines, using that lines dot contains so a particular name, and then it will take you into the particular thing. So if at all you want to display, you can do that one. So let's see, let's try to run this program and then perform, whether this transformation is working or not. So let's see that one. Alright, I have this file, Hadoop mp. Word count is available. Hadoop fs minus cat some data is available. So my aim is to, let's try to load this file into this particular variable. Okay, val text file equal to half. So this particular path we can give. So file name, I am making it as a RDD. I am making this file into the RDD, and then press enter. So RDD has been created, right? Now, so I would like to make the transformation using this one. So this is one of the variable. From this variable, so I am making this lines contains this function. Okay, so I am taking another variable, lines contains word equal to, so is so what is my file name earlier? So t file, right? Right. Right. T file filter lines contains is. So now I would like to print that lines contains word, this whatever the contents which were there. So I'm here, I am getting so all the lines which contains is keyword. So this is using filter function. I am making transformation. So from the transformation, this is nothing but another RDD. So main RDD, this is RDD, text file is RDD. From this RDD, I am creating another RDD. So from this RDD, if you want to get the results, you need to perform the action. What is the action? I am printing that is an action. So if at all you are making an action from the RDD, then only you will get the result. So my result is, I would like to display the result out of it using print statement. So that is my action. So I have done that one. I can see what are all the lines contains is keyword, right? So third program is identify length of each line in the file. So I would like to get length of each line. Okay, so this is also using map function I am doing. This is map is a transformative function. Okay, so using collect, I am collecting that one and then storing into the one of the, so this is collect or count. So these are all the some of the functions available, right? So let's see that one as well. So identify length of each line in a particular file. Length. So same thing I would like to refer here. So first of all, I am taking this file into the one file. So that is my action. Done. After this, I would like to perform this operation. So T file, right here, right? So here line with counts, right? Line dot length, which will tells you what is the length of each line. So you can collect all the things into the one of the variable, or you can print it. If you want to print it, you can print that one as well. So how do you print? So this is where you can print. Yeah, each word. Hi, how are you is 14. Its length is, so its length is 13 words. It contains 35 words, 35 characters, sorry. Its length is 42 characters. Like this way you can perform all the actions. Like that way, my fourth program is identify total length of all the lines. So total length of all the lines I would like to. So this is one action. So this is one transformation. This is another transformation. So here three things are there. So first let's execute one by one. So taking the file. So this is, I am taking the file. So that's fine. Done. So my next operation is, so I would like to first of all identify the length of, I am taking here, I am identifying length of each thing, each line. After that, so here I am getting length of each line. So here I am getting length of all the lines using this function, right? You can execute that one, right? Total count, so that is length of, that's it, 137, which has been displayed. So if at all you want to display what are all the things which contains in this particular total length, so if at all only particular value will display, right? Sorry, I'm taking the file. I am getting length of all the lines. After that, total count. Here I am getting in this variable total count. So here total count is 137, right? So this is the function total count. So reduce method, so count the things like that way, and then it will display here itself total count. If at all you would like to, so reduce method itself it print the things, so that it's not an issue. So next thing is convert lines to words. So if at all you would like to divide how many words in particular line into number of words, so these are all the functions available. So flat map will do like that way, okay? Right. So let's first take the data, right, and then after that, right. So if at all you want to display the contents of this one, So print it. If at all you want to save it, I'll show you how to save that. So these are all the words. So lines I am dividing into the number of words using flat map. So if at all you would like to get the word count example, so this is what. So word count example. First I am dividing into the number of words. After that, so I am assigning one numeric value, and then using reduce by key function transformation, I am counting all those things. So let's see this one word count example. So in simple lines. So first of all I am taking the value into one of the file. That is done. So now I am using this one. I am dividing into number of lines, right? Sorry, number of words. Done. So next thing is I'm for each word I am adding some static value 1. Done, right? So and then for I am counting how many words are there, repetitive words, using reduce by key function. So if at all you want to print that one, so same function. Yeah, so how many times each word has been repeated? So is 3. So this is a word count example, right? If you see in map reduce, how many lines you would like to code? You would like to code up to some 200 to 250 lines, but here simple 4 lines. Our task is done. So this is a simple language. Scala is a uses simple Scala language. We can achieve that much of complex things very easy way on top of the Spark. So my another program is identify top 2 words. So top 2 words. So first of all I am using word counts. So I am getting that data. Word counts contains these word counts contains my data, right? So using that one I am just simply counting what are all the top 2 words, right? So here map method will be so sort by key. So that is this is one transformation, this is also one transformation. From this transformations how to get the result, this is the way, right? Sort data and then take top 3 things, right? So these are all the simple functions techniques available in Apache Spark to achieve the desired functionality. Even in MapReduce, if you want to code that one, you need to code multiple lines of code. So this is the way you need to this is the way you are going to save your things into the HDFS path. Save as text file, and then path you need to specify. Okay, right? Yeah, top 3 things. So contains top 3 words. So 3 and this contains array. So 3 3 2. So this is what it contains. If at all you would like to store this, or you would like to print this, sort data, right? Sorted data. So sorted data top. So if at all you would like to take top to, so what is the function to take top to? So sorted data dot take top to. So into one variable, right? So val top to equal to take two functions, and then top to, print top to. Sorry. Yeah, it will take you only top two things and then printing here, right? So array it will make the array internally and then it will collect the data. So if at all you would like to save these things into the output files, output path, this is the save as text file, and then give the path. So that's it. Okay. So this is the way you can do that one. Everything will be possible, whatever the functions I have shown in the PPT. So if at all you are creating some Java application and then you would like to if at all you would like to deploy that whatever the jars you have created using Java applications, so this is the using Spark submit, you can submit into the on top of the Spark cluster, so that it will identify a particular related class and then execute with help of the workers, executors. Okay. Right. So this is what about Apache Spark.